Today we will see the next chapter, that is chapter number 5, which is straight line. Okay. So before we are going to straight line, there are some terminologies we should know. So I would rather put it as a coordinate geometry, and then let us see what straight line will go for the next exercise onwards. Fine. So what am I going to do? We know the coordinate system, right? X and Y in a 2D. Okay, we are discussing only the 2D coordinate system. That's the plane coordinates, not on the 3 dimension. Okay, so we are having a coordinate system like this. So this is x minus x, correct? Y and minus y. I am going to have a point. I am going to make a point P, which is x comma y, and this point is at a distance. Let me put it up. So the distance between the origin and this point is, say, let us say R. Make it slightly bigger. Now I am asking you, so this is the origin of the coordinate system we have, right? What is the origin? What is the origin coordinate is? 0, 0. Very good. So now I am asking you a question. Can you draw another point which is at a distance R from O0? Can you plot another point? You can able to draw another point in this coordinate system which should have the same distance from the origin at R0. Is it possible for you to draw? Where?
Minus x, minus y.
Xy is general. Maybe somewhere else here, right? You can draw a point. So then what am I going to do? I will have another point here. Let me use the only single color. So this will be here. Say let that it be Q, which is say some value. We don't have to bother about it. Okay. So this distance is also R. Can you draw in one more point? We can draw say something like that here. We have another point. Okay. So this is also R, and there will be some other point. I can keep drawing this point. How many points I can draw? Infinite points. Okay. So can you tell me what the points will make us? Correct. So what happened? So these points, which is at an equal distance, the points on the coordinate system, which is satisfying a condition. Correct? What is the condition? The distance from the origin should be R. Okay, so this is a coordinate of points which is basically satisfying a condition, that is our distance from the origin is equal to R. That point is a circle. Okay, and I can do one more thing also. Instead of this point 0, 0, I can ask you it from some other point also, right? I will tell you, okay, I don't want from this point 0, 0. I will take a point here, say let it be 1, 2. Okay, I am asking, there is another point I am drawing, that is say some other point. Okay, I will define a small p. Okay, so this distance is say something different A. Now I am asking, can you draw one more point of same distance A from this point? Okay, so let us name this point as, say some name. O, okay, no, O is origin. So let us another name. Okay, Q. Let us make it as Q. Okay, so this QP is A. Now I want to make another point which should have the same distance from Q as A. What it will be? Circle with the center.
Q.
Correct. Because this is A, I have to keep drawing out. So what we will get is another circle with a center Q. Okay, so this set of points, this infinite set of points satisfy one condition. What is the condition? The distance between every point in this infinite set of points, every point satisfy a condition. What is the condition? The distance of that point with respect to Q will be A. Similarly here also, this is an infinite number of points, but all the points satisfy a condition. What is the condition? The distance from the origin is R. Okay, so we can still make some more plots also. This is only for a circle. Not necessarily I have to plot only a circle. One very easy example is I'm giving you 2 points. So let us say this is your P and this is your Q. I'm asking you how many points you can draw which will be equidistant from P and Q. Got it? So that means if I take a point here, which is if I join a straight line, if I take a point here and let me call it as M. So if this is a center point, so then this is equidistant, right? If M is a middle point, so then this is equidistant. So for example, this also will be A and this also will be A. This length will be A and this length also will be A. So you can have only one point or you can have some other point which should have an equidistance from P and Q. Only one point. I am not asking the point should be on that line. I am asking you any point. Can you place any point? The only condition I am not saying A. The distance should be same. It not necessarily this should be A. Can't you draw any other point? Above. Correct. So this also will have equidistance, right? So how many points you can draw? Can I draw one more here? Can I draw one more here? One more here? Can I draw bottom also? Okay. So this will be what? What is this line compared to this? Perpendicular bisector. Correct. So what is the condition here? I am defining all the points, the infinite points which is falling on the perpendicular bisector. These points satisfy a condition, that is they are equidistant from the 2 points. So the condition is what? Every point which is equidistant from P and Q, you will see that's basically a perpendicular bisector. Okay, so in this line, the points on this line will follow this criteria, that is these points are equidistant from the P and Q. Similarly here, the points on this circle, they follow a criteria, these points are equidistant from a point O. So what you see, when I draw points which is equidistant from a single point, what do you get? A circle. When you say the same thing, when I say the point which is equidistant from 2 points, then it won't be a circle. It will be a perpendicular bisector. But only thing is here the condition is, means this distance has to be R. Okay, here I can't have. If I say there has to be equidistant and its value should be A, then it comes out to be only one point, that is the center point, what you said. If I say no, I don't have the problem with whatever the measurement, but the question is they should be equidistant from these 2 points, then it forms a perpendicular bisector. Okay, these are all our coordinate in the geometry. Okay, so you can see, suppose if I take x-axis, if I take 2 points, here it is -2 and +2, then y-axis is the equidistance point, right? Perpendicular bisector. Fine, so this is the one, and it's not only that. So what I want to say is not just a circle. You can have many conditions, right? So I can keep drawing, making more and more conditions, whatever the conditions I want to do. Or for example, there's another one example which is given in your book is, for example, okay, so I'm having from the origin. This is another point, P. Okay. And I'm saying you have to find out draw the points. Give me I'll ask you, give me a point whose distance, the perpendicular distance from the OP and OX is same. That means what? I'm asking you, give me a point such that this is the perpendicular distance from OP and this is the perpendicular distance from OX. Correct? So this distance has to be same. Correct? So A can be anything, any number. Can there be only one point or can there be many points?
Many points.
What? Can you tell me one point where it comes, where you draw?
You take the point bit backwards towards the
Here. Okay. So then this distance will be same as this distance. That's what you are saying. Am I right? So, and similarly I can draw another point. So, this if it is B, this also will be B. So, similarly I can have another point also. Correct? So, this is one perpendicular direct bisector from here. And this is also perpendicular bisector from here. So, this is if it is C, this also will be C. So, what will you see? All these points will fall on a line. Correct? And what is that? This is a angular bisector. Am I right? If you remember, this is angular bisector. Okay, so this is angular, so that was a perpendicular bisector. Okay, so what we have said, if all the set of points which is equidistant from another point, equidistance, okay, that will form a circle. All the set of points equidistant from a point circle, all the set of points which are equidistant from two points, that will be a perpendicular bisector. All the set of points which is equidistant from two rays, this will be rays, let us write it out, rays or whatever. Okay, so two rays will be the angular bisector. So we can still keep drawing many and many conditions. Okay, so and in general what I want to say is, how this problem should be looked is, how do we look at this problem is, so let us take out this problem out of circle. Okay, this is a point I am saying which is at a distance, how much? R. Now I am questioning, so this point is having an x coordinate and a y coordinate. So let us call it as x1, y1. Now the question is, when I move this x coordinate towards maybe right or left, wherever, to a new point. So let us take it, let me move to x2. So this is some x2. The question I am asking is, when I move this point, when I move this coordinate to x2, what should be my change in y? You got it? So in a circle when it comes, when I move this point from x1 to x2, that is here, right? Here, okay, so this has become x2, then your y will move from here, correct? Y will move to new point y2. Okay, so a circle, in a circle it is very defined. When I move my x1 to x2, I should know what will be my y1 will change to y2. It can't go like this because it's a circle. So there's what will be the new point is very well defined. How it is defined? Because they all are connected. Because I started with the condition, this point should be equidistant from the center. Okay, so this is a condition. That's what any point, when I move that point to another point, means when I change the x from x1 to x2, you will see y1 also has to change. How it will change? Depending upon the condition where we started with. Okay, so similarly you can take it to y also. As you move y, x has to change. You can look it in that angle also, reverse also. Now, okay, and then then I will give another condition. I can make a very simple condition. Y equal to x plus or 2x plus 3. Do you know what this is? It is a straight line. Am I right? The equation of a straight line. Because if you write, then when x is equal to 0, y equal to 3. Am I right? So this is a one point, this point lie on this straight line, x0, 0, comma 3 lie on this point. So I can say this is a 0, comma 3. For example, let us take. Okay. And then another point. You take it, when x is equal to 1, what it will be? Y will be 5. So when x is equal to 1, let me say if this is the 1, okay, y will be equal to 5. So this will be something like this. This is 1, comma 5. Am I right? So then x is equal to 2, what will be? Y will be equal to 7. Right? So when x is equal to 2, y will be equal to 7. So this is some point somewhere else here it will come. Okay, let us write just something like that. This you have done in your 10th standard, right? So you will find all these 3 points will be a collinear, correct? It's a straight line. So again, I will say this is also a set of points. Am I right? Correct? What the set of points which satisfy this condition. Here what happened? We had the condition was equidistant from a point. Perpendicular bisector equidistant from 2 points. Okay, angular bisector is equidistant from 2 lines. And this is a set of points which follow this equation. Okay, this is also a condition. Y should be such that twice x plus y should be such that twice of x plus 3 should equal y. Again, same condition, correct? Here also, y should be such that the distance between xy and 0 should be equal to r. Okay, so everywhere having a condition. So this set of points, okay, which satisfy set of points on the coordinate system, which satisfies certain geometrical condition, is called as a locus. You got it? This is the locus. So what is the point we call? These are the points. So this circle is a locus. The points forming the circle is a locus. The points forming a perpendicular bisector is a locus. The point forming the angular bisector is a locus. Even the point forming a straight line is also a locus. Okay, because why? So the condition is what? The set of points which follow a certain geometrical condition. That's what your locus is. Okay, so what is the spelling? L-O-C-U-S. Okay, and the plural form is loci, L-O-C-I-I. Okay, so we don't have to bother yeah. Okay, so then, okay, how do we represent locus? So, yeah. So then the locus, let me denote the symbol of locus as L. So then, yeah, written. Yeah. So then how locus is defined? Locus is a set of points which I denote as P, okay, such that point P satisfy some certain geometrical condition. Got it? So that's what, okay, one thing they have written is point P is in a plane. Locus is a point where point P will be there, is in a plane and satisfy certain geometrical condition. Okay, it's still a plane because we are doing only the planar geometry. For us, the third dimension doesn't exist. Okay, the third dimension is Z axis. Okay, it doesn't exist. So this is the, okay, so now you understood what do you mean by locus, correct? So locus is a set of points. So in a coordinate geometry, in a this we call as 2D coordinate geometry, 2-dimensional geometry. So this locus of point has to be defined. This defines the different curves and different circles, different lines. Even when you draw a second quadratic equation, which will be, you read about parabolas? No, right? Okay, you will see. Even quadratic equation will not have a straight line, will have a certain curve. Am I right? This all the lines, all the curves you draw on a plane will satisfy certain condition. They are not arbitrary points. That point should fall on some curve. Okay, so those points basically called as your locus. So you can look it the other way also, as I explained here. So locus is one the set of points which follow a certain geometrical condition, you call as a locus. Okay, you can see locus also, if I start moving this point towards x, what should be my y? That also defines locus. One and the same. I can see what is the movement of the point given condition. So one example they given in your book is, okay, it's a very common example. The earth, movement of earth around the sun, right? So earth is not moving arbitrarily, randomly here and there. It doesn't have a definite path, correct? So that is a locus. Okay, but remember locus when we say it from a point. There's important definition of a point. Do you know what the definition of a point?
It's in 2D.
No, point can be in 3D also. The definition of point is point size should be 0. point should not have a size. If you ask me what is the size of the point, it doesn't exist. Here, of course, now I made a point, then you can't bring up a scale and say, oh, point is this much of thing. Okay. By definition, mathematically, point is something which do not have a size. Now, when I say earth and sun, earth is having a size. Earth is not a point. But you can assume earth as a point because that size is very, very, very small compared to the distance between the sun and the earth. So, you can always consider it as a point. Otherwise, what they call is center of mass. You have learned of center of mass in physics? Okay, yeah. When you come center of mass, every object can be treated as a point that you learn in physics. Okay, so that's okay. Fine. So this is the locus. Now you got idea about what they mean by locus? Okay, so this is how you define a locus, and in short, every curve is formed by infinite number of points, and that infinite point is a locus. Okay, which should satisfy this condition. Good? Fine. So let us do some examples, but before that I want to do one more thing in the coordinate geometry, which is actually very, this, one of the important thing in this coordinate geometry is the origin. Am I right? Where you put up the origin. Okay, and this is a very confusing thing. Okay, why it is confusing is because there is nothing like an origin in reality. In a real life, you can't have origin. Means origin is your personal choice. Correct? Let us see. Let us say, for example, let me draw it down. So what is the origin? Suppose, for example, let us see the problem in a 3-dimensional problem, but we will see it in a 2-dimension. Okay, so what we are going to have, let us put up a simple way. There is a tree. There is a tree. Okay, and there is a fruit hanging on the tree. Okay, so now, you are standing here. And another one of your friend is standing on a, say something like your ladder or whatever. Some elevated point is there. He climbed over by the ladder and then he was standing here. Okay, now he's asking you what is the coordinate of this apple or the fruit. Okay, what the coordinate you will say, okay, this is at this much of height and this much of distance far away from it. That this is your x distance, this is a y distance. So you will say, so according to you, you will say this distance, let us call it as how much? Say a. And this height, we'll call it as b. So you will say, for me, the coordinate of this fruit is a comma b. And if he thinks of your coordinate, he takes your coordinate very seriously. And if he is throwing a stone to hit the fruit, where he will throw the stone? He will throw it here. Correct? Am I right? So, what happened? Because, why he throws it here? Because the origin, the coordinate system, what you use, have a and b. But the coordinate system is in a different coordinate system. He is going to see the fruit with a different coordinate system. For him, it will not be a and b. So, he will have some coordinate, may not be here. For him, the x may be, if is exactly, I have drawn it parallel. Let us put it up here like this. Let us do it here like this. Okay. So, for him, this is the x coordinate and this is the y coordinate. Am I right? This distance. So, he will measure for him the same fruit of a different coordinate, that is x comma y. And x is not equal to a and y is not equal to b. Okay, so what you call this problem as your shift of origin. Basically what happened, your coordinate frames are not fixed. So you are using your coordinate system where your origin is lying on your eyes. For example, let us take where your eyes this is your x and y. For him, this is the coordinate system. I will call this as x prime and y prime. Okay, so those coordinate systems are not same. Why they are not same? What actually have happened? Your origin is shifted, correct? In your case, the origin may be O. For him, the origin is O prime. So now the question comes. So you gave the coordinate. Now he has to convert that coordinate with respect to his reference coordinate system, and then only he can throw a stone. Okay, then only adjust, okay, this is the height, I can throw a stone and hit the fruit, apple or whatever. Okay, so this is what we call as your shift in origin. What is that? Okay, this problem is called as a shift in origin. So in a coordinate system, since your origin is going to be different for different people, you need to have development method how you will be able to, I am giving you a coordinate, how you will be able to connect your coordinate with my coordinate system. So this is important. In reality, you are not going to do all these calculations to throw an apple. You simply take a throw and you will some 100 times you will throw and one of them will hit the apple and it will fall down. Okay. But mathematicians will always do this. Okay. Okay. Fine. So let us see about the shift in the origin. What happened? What do we mean by shift in the origin? So let us, okay, the same problem, we draw it in a more neat way. So what is this? Okay, let us draw a coordinate system first. So let me call this as your x prime. Okay, and this is your this is x.
That is
Y. Do you know? Even x-axis have a condition. Do you know that? See, x-axis is also a set of points, right? It is also a locus. And what is the condition for that locus? Tell me. What will be the value of y in x-axis? 0. Okay, so here the locus condition is y equal to 0. X-axis is also a locus with the condition y equal to 0. Similarly, y-axis is also a locus with the condition x equal to 0. So that's the thing. All curves in this coordinate, what you draw in a plane are basically locus. Okay. If you don't define locus, then the points can be absolutely scattered. That's why I say, if I suppose assume these are the points made up of infinite number of points. So you can assume, let's say, images. Suppose if I just relax the condition. So now all these points are constrained by one condition. What is that? My y should be equal to 0. The moment suppose you think these all are tied up with the condition is a rubber bands. These all are tied to the conditions y equal to 0. The moment I remove those conditions, that's a rubber band, then the points will completely scatter, correct? Then the points will fill up the space just as the points. Okay, so that's what the locus. Locus is something condition which ties the point in a certain curve. Okay? Okay, fine. So let us do this one. So I am going to have another coordinate system. Suppose this is your coordinate system and your friend is on some elevated ground. So, and let us call this is his coordinate system. We will call it as x prime and let us call this as a y prime. Okay? And so, okay, his origin we will call it as a O prime and your origin we will call it as a, what's the origin we will call it as? O. Okay? So what we have to do, we have to find out a certain coordinate point. How we are going to classify the point, how we are going to define the point in both the coordinate systems. So let this point be what I will call it as a P. Okay. So the P have two coordinates. Am I right? One is corresponding to U. Okay, let me use it in black color. The black corresponds to your measurement. So you have measured this point as x, y. And your friend has measured this point as what will be x prime, y prime. Now the shift because there is a shift in the origin, you need to know what should be these points, how my x and x prime are connected, y and y prime are connected. So that is the problem of shifting in the origin, because you shifted the origin. You can, by looking itself you can tell, correct? So what is that? See, how will we do it? Okay, let me extend this line. This has become too short. This is your x and this is your y. Okay, so what we are going to do, how I am going to do? Okay, this also will extend it because this is also looking shorter. Fine, so this will be your y prime. Now, okay, so let us try to understand. So your friend measured x prime y prime, that means this distance is x prime, correct? And this distance is what? Y prime. This is what I measured by your friend, correct? And now you have measured as xy, that means what? This distance y and this distance x, correct? Now the condition is, now you want to know how this x and x prime and y prime are connected. It is simple, right? How do you find it out? You need to know this distance. Okay, so we need to know this distance. Let us call this distance as h. That means you should know at what point your friend is sitting. You know, your friend is standing on some tower which is at a distance, which is at a distance, say, let us say, for example, let us take this distance as h distance away from your x-axis, and not just that, over the height also, right? So this will be, or you want this as k, let us say it as k, and this is the distance, this is the distance between the two origins, you got it, na? K. Okay, just by looking at it, you can say, I done both as k, this is h. Okay, so what I am saying is, you are standing here and your friend is standing here. Your friend is k distance away from your x-axis and h distance above in your y-axis. So from here, can you tell me how your x and x prime are connected? X will be equal to?
X will be equal to x prime plus k.
Correct, x prime plus k. Where is x prime? And plus k, correct? And y equal to?
Y prime plus h.
Y prime plus h. And remember, this is allowed only the coordinate system what you are using, your axes are parallel to each other, correct? Suppose your friend is not standing, he is lying down and he is seeing like this. In that case, what happened? Your friend coordinate system may shifted like this. If this guy is, funny guy is lying like this, then of course this coordinate system this is the coordinate system he is using. Then it won't be satisfied. Okay, then you have to use another law, that is your angle also will come into picture. That you will study in your higher classes. Okay, so for your present class, this is sufficient. What happened? Your friend is a decent friend. He is not lying down. He is standing erect. Okay, so this is what? This is for when your axes are parallel. This is how these coordinates are connected. Okay, so this is a very funny way I written it simply, but you want to explain it a very mathematically, then you have to explain. You have to make these points. So let us call what you do, how we do it, show it in a very neat way. Okay, fine. How do you show it in a neat way is, let this be O prime, and let us call this perpendicular, this y prime hit your this frame at, say something, give some numbers.
7.
Not a number, I am saying symbol. Give a symbol. We can't have a point named 7. Okay, let us call it as A. Okay, so this point is A, and this point is B, and this point is C, and this point is D. Okay, then you can find out. So then we will have, so your let OA be equal to OA be equal to K, and what? OC will be equal to H. Okay, and then from Okay, yeah, fine. So here they use different. Fine. So then OB equal to OA plus AB. So OB equal to what? That is your X. OA equal to K plus AB is equal to what? AB is here this friend's measurement, X prime. So we got one measurement. Similarly, OD equal to OC plus CD. What is OC? OC is H and CD is your friend's Y measurement, right? This is your Y prime. Okay, so so you have to draw. You draw a perpendicular from O prime such that that perpendicular hits on your x-axis at A, and similarly draw a perpendicular from O prime to y-axis, let that intersect on C. You have to write all those in the exam. You write all those points if they are asking it. Okay, so fine. So you got it clear? So what we saw today, two things. One is locus of points. Another one is shift in origin. Okay, so shift in origin, this is the condition, you have to use it. Okay, suppose for example, remember this H can be positive as well as negative. If this point is somewhere else here, yes, X will be negative, Y will be positive. You got it? If it is here, so it can be anywhere else. So you should know what is the sign also. It is not always precise, you know which point is where. Okay, so let us do some problems. Okay, let us do some problems in both in locus and shift in origin. Yeah, so I will do some 2-3 problems. I will do all the simple problems and you can do your tough problems, right? Okay. Yeah, if you have no problems are tough, only thing you should understand it properly. Let me take up a, yeah, this is an interesting problem. Okay, actually, in fact, you don't have the book they given as some number 4. It is not necessarily it has to be number 4. Okay, so I'm asking you the problem on locus. Okay, let me put up the condition. So what is the problem here? As a circle. Fine, yeah. Let L, which is a locus, is P such that OP is equal to some A, some constant. Okay? A can be any number. In the book they given it as 4. I am taking it for A. Anything will be there. Find the equation of L. Equation of L means the condition. What is the curve? Basically, what is the equation of the curve? Okay, simple. Let us do. Let's try to think of a coordinate system. So this is O. What they have said? O is origin, right? You have taken up a point P such that OP is equal to A. So this is the condition he has given. So what it will be? You know, this is going to be a circle, correct? Because if you make it up, all points should have a distance A, this circle. So let us assume this be any general point which is X comma Y. Okay, so what is the condition? So we need to have the distance between these 2 points should be A. You know what is the distance, right? What is the distance OP? OP equal to square root of x1 minus x2 in plus y1 minus y2 whole square. Remember, 10th standard, correct? So if you have 2 points here, so this is the one. So what happened here? x1 is x minus 0 whole square plus y minus 0 whole square. So this will be what? X square plus y square. They are given already OP. OP is equal to what? A. Correct? So now if I want to remove the square root, I have to multiply by square both the sides. So what you have? A square equal to x square plus y square, or x square plus y square equal to a square. This is the equation of the locus. Any x and y which satisfy this condition is going to be a circle. Correct? So this is what? Equation of the locus. You got it? So when your equation of a circle is what? X square plus y square equal to a square. It is not necessarily OP. Okay, I can always give another value. Okay, I can even, you can even find out a different problem also. Suppose if your, so if a locus is given like this, P such that, okay, AP is equal to A and A is x1 comma y1. What is that? That means y1. What it means? It means you are drawing a circle around a point A. Am I right? So earlier we draw a circle around a point O. That's the origin. So what it says is, now I am not drawing this locus says you are not drawing a point around the origin. You defined a point A, which we are calling it as x1 comma y1, and then you have, that's the point x1 comma y1, and then you have to fix up a point AP. Let this point be P, which is x comma y, in general I can call, such that AP is A. Correct? So that means this should always mean this is a circle around this point. Still you can find out the locus of it. So what is the condition? AP has to be always constant. Correct? So what is the distance AP? Tell me. AP equal to square root of?
X minus x1 whole square.
Correct. X minus x1 whole square plus y minus y1 whole square. Okay. And AP is what? A. A equal to square root of x minus x1 whole square plus y minus y1 whole square. If I square both the sides, so then the a square root will go off. Okay, and therefore the equation of the locus L will be x minus x1 square plus y minus y1 square equal to a square. So this is the general formula of a circle in 2 dimension. Any circle drawn around a point x1, y1 with radius a will have this equation. So this is the equation of a circle. You got it? Fine. So let us do one more problem. Some more problem, because give some 2-3 problems. Okay, this is a very interesting. Are you clear? Any doubt you have? No. Okay. So this problem is also interesting. So let's find the equation of the locus of points which are equidistant from A, which is minus 3 comma 0, and you got it? I will start giving 2 points. So it cannot be a circle. Correct? And B, which is 3 comma 0. That's it. And you have to identify the locus. Correct, yeah. The locus. Let us see. Of course, that is the easy answer. Because that we already found. Now, if it is equidistant from 2 points, it has to be a perpendicular bisector of AB. Okay? So, in this case, fine. How we are going to write the solution? Tell me. Equidistant, find the location of a point which are equidistant from A and B. So what it says, if I draw the coordinate system, like that, okay, we can actually mark the point also. A is what? Minus 3 comma 0. Where it should be? It should be somewhere else here. Am I right? This is A, this is minus 3 comma 0, and this point is 3 comma 0. So that itself gave you an answer. What is that? What should be? No, origin. Origin is
Origin is the point of equidistance.
equidistance. No, but
Perpendicular by
yes, the y-axis. It will come as a y-axis. We will find it out. You got it? Not origin is only one point. Locus is at a point. When you say, see, they are just telling you equidistant, but they are not telling what should be the distant. Any point on y-axis is going to be equidistant from this point. Correct? So let us show it nicely mathematically. So what happened? So it is equidistant from point A and B. Okay, solution. Let P x comma y be the point equidistant from A and B. Therefore, AP should be equal to BP. Am I right? So what is AP? A is given, correct? Okay, A is given. A equal to what? A is equal to minus 3 comma 0 and B is equal to 3 comma 0. Okay, don't ask me what are the triple signs and all that, you will understand in the higher classes. Okay, so rather if you want it, you can write just like an arrow. That's more easier for you to understand. Okay, so therefore AP is what? AP we already given xy, correct? So square root of x1 minus, right? So this will be what? Tell me fast.
X plus 3
whole square.
plus,
That's it.
Y plus y minus 0. No.
What is it? Y square. Why are you thinking so much? What is it? BP? Tell me. BP is equal to
X minus 3 whole square
minus 3 whole square
plus y square.
plus y square. Okay. Since they both are equal, AP square should be this one. Am I right? Similarly, BP square should be this one. Am I right? And AP square is equal to BP square. So for what? X plus 3 whole square plus y square will be equal to x minus 3 whole square plus y square. Correct? So what it will be? Tell me.
But x plus 3 whole square is not equal to x minus 1 square.
Correct?
X plus 3
Of course.
whole square is not equal.
Of course. Of course, you're not going to same. So this will be what? This both will cancel. So x plus 3 whole square is what? X square plus 6x plus
9
plus 9 is equal to, this will be what? X square
minus 6x
minus 6x
plus 9.
plus 9.
So 6x equal to minus 6x.
Hmm.
So if you reduce it, 6x equal to minus 6x.
What you are getting? 6x equal to minus 6x. 6 has to be same. So if I divide both sides by 6, what you are getting? X is equal to minus x. When it can happen? Only when?
0.
Yes, only when x is equal to 0, this is going to happen. Otherwise it can't. Okay, no number is equal to its negative of its number. Only when it is 0. So when x is equal to 0, what is that? What is the equation of y-axis?
So y is x equal to 0.
X equal to 0 is the condition. Okay, so what happened? The locus is nothing. Therefore, what you have to write? The locus is the y-axis. Correct? So this is the problem with the locus, and we will do one more problem. One more problem in the shift, what is that? Shift of origin. Okay, and then I will stop. Okay, so this is very interesting. We have to find out with the. I'm okay. I'm just straight away combining a problem of shift of origin and the locus. Okay, you can have there are individual problems with shift of origin. The shift of origin is very simple. Okay, I'm going to give this problem. Obtain. See, that's what I'm saying. Why this is important is you are having a locus, correct? Locus is nothing but an equation, right? So now, see a bird making a circle. For you, will be a circle have a different equation. Someone standing somewhere else, he will have a different, right? Because origin has shifted. So this question is how the locus will shift when your origin is locus will change when your origin is being shifted. So that's the problem. What happened? Obtain the new equation of the locus. Of the locus. Okay, so the locus is very lengthy. X square minus xy minus 2y square minus x plus 4y plus 2 equal to 0. You got it? Even this is a locus because you define your x and y should always satisfy this condition. Whatever circle or simple we got, this is also locus. That's why any curve you can represent by this equation, and that is a locus. Okay. When the origin is shifted, to 2,3. The directions of the axis remain same. You got it? What the last word means?
Okay, the same.
The parallel. Yeah, they has to be parallel because that has to be remained. The origin, when you shift the origin, is under the condition only the axes are parallel. If there's rotating, then you're going to have a different angle informations will come. Okay, this is a solution. Let us do that. It's actually very simple. So what the problem says is, okay, I'm having this coordinate system. Let us say this is the initial coordinate system where your origin is 0, 0. And there is some curve. This is a locus, correct? And this locus is given by these equations. This complicated x square minus xy minus 2y square, one like that. Now what it says is, so now you are shifting your origin from here to 2, 3. That is what? Let me say this is 2 and this is 3. So this is 2, 3. So what should be for this coordinate? So that means you are forming a new coordinate system. Am I right? So what should be the equation of this locus, which you defined in this new coordinate system? Okay, so it's simple. Tell me. So let us call this as your x prime, and y prime. So then the points be x prime and y prime, correct? Let us take one point. We have to just find out with the one point. Let me take one point in the locus. So this point measured by this axis will have x comma y, and whereas from this axis, yeah, I should use the red for here, x comma y, and for this axis it will be, yeah, x prime comma y prime. You know how this x prime and y prime are connected, correct? So tell me now what will be your x? X will be equal to
X prime plus 2.
x prime plus 2, correct? Because this is the point, right? So, and this is the distance. So, this is x prime, am I right? This is x prime and this is nothing but 2 and this is your total x. So, x is equal to x prime plus 2. Similarly here,
y equal to y prime plus
yeah.
3.
So, this is a what? So, this is your y and this is your y prime because this guy is measuring from here. Distance is given as 3. Okay, so what happens? So, y equal to y prime plus 3 and that's short answer. Now, you just substitute from here. Okay, from here what you can write? They given in x, right? So, from this gives you x prime equal to x minus 2. This gives you y prime. Oh no, sorry. This is okay. Yeah, correct. And that's what you want. We don't have to substitute. Yeah. So let us write this function. I will call it something as f of x. F of x is equal to x square minus xy minus 2y square minus x plus 4y plus 2 equal to 0. Okay. So now we want to find out this locus in prime. So we will not L, we will write it as L. Okay. Now we want L prime. Am I right? The new one. So L prime will be what?
X prime plus 2 whole square.
X prime plus 2 whole square minus x prime plus 2 y prime plus 3 minus 2 times
y prime plus
3 whole square
minus x prime plus 2
minus x prime plus 2
plus 4 times y prime plus 3
prime plus 3 plus 2 equal to 0. Okay. I open it. Simple. What is going to become? X prime square plus 4x prime
plus
4. This is minus is there, right? Minus x prime minus 2.
minus
Oh, sorry. This product is there, na? So minus
x prime y prime
x prime y prime
minus 3x prime
3x prime
plus 2
y prime
plus
plus 6. Okay, and then this one minus 2 into y prime square plus 6y prime plus 9. Then tell me this.
minus 4 times
This x prime is na? X prime minus 2. This is
plus 4y prime
4y prime plus 12 plus 2 is equal to 0. Let us open all the brackets. Okay.
x prime to the square
X prime square
plus 4x prime plus 4 minus x prime y prime plus 3x prime minus 2y prime minus 6 minus 2y prime
square
y prime square minus 12y prime minus 18
12 y prime minus 18.
minus x square x prime square
Oh, sorry, x prime square. Yeah, correct.
minus 2
X prime square. No, x prime. It is just x prime. I wrote it as square here. This is this one, na? Minus x prime. Minus x prime minus 2. Okay. And this one is
plus 4y prime
plus 4y prime
plus 14
plus
14
12 plus 2 14 equal to 0. Tell me what's the answer? X prime square, is there anything x prime square? Nothing. So only 1 will come. Correct? X prime square. Let us go the same form. Then the xy term. Okay, x prime y prime term. Combine all x prime y prime term.
minus x prime
Only 1, right? Minus x prime y prime. Yeah. And then y square term.
minus 2y square
There's only 1 is there, right? Minus 2y prime square.
then x terms
X terms you have many. Tell me how much it is.
plus 4x prime 4x prime plus 7x prime
4. These are the one, na? So let me mark it. x prime. Okay, x prime, this is here, this is here,
And minus x prime is
this is here, correct? Only this much. Am I right?
6x prime.
You're sure? We haven't missed anything, right? Plus, yeah, these both will, okay, 3, okay, yeah, no. 6, 7 minus, yeah. Plus, right? Plus 6 x prime y prime. Correct?
Only x prime. Only x
Oops, sorry, only x prime. Yeah, yeah. Only x prime, yeah. Then the y prime. Let us go for the y prime term. What are the y prime terms?
Minus 2y prime.
This one.
Uh,
Sorry, let me make it as
minus 12.
y prime,
Minus 12y prime.
right? And this one. Correct? These three terms.
Minus 10y
14, minus 10. Minus 10 y prime, correct? Minus 10 y prime, you have to be careful. This can be a wrong also. Yeah, that's right, we are getting.
minus 6.
Because
Minus 8. Minus 8.
he is not having any x prime here at all. I guess in the book they have done the mistake, or the x prime getting cancelled. 4x prime, 3x prime. I guess this is minus 3x prime, is there? Yeah. We made a mistake, na? You see. How this can be minus? This is plus, na? Correct, na? So this becomes, so it becomes minus. Right. That's the reason. See? So then if minus means 4x prime minus 3x prime minus x prime. So this can go 0, correct? So this goes off. Okay, so what we have?
Minus 10y prime.
Minus, right? 10 y prime. Is that correct? Yes. Yeah.
Minus 8.
The final one is minus 8. You calculated. 4 minus 6 is minus 2. Minus 2 and minus 20.
Plus
Minus 20 minus 2.
minus 22.
Minus 22 plus 14. 8. No, minus 8. Minus 8 equal to 0. Yes. So that's the. So this is your new locus. Okay, the new equation of the locus is the new equation of the locus. Not locust. Okay? Clear? Okay, so now you do all the other problems in the exercises.